going to present on the topic operating system architecture. Before going on the network and distributed operating system, let us see what is operating system architecture and how the operating system architecture affects the performance. So, operating system has the responsibility of managing the resources, establishing a platform for running different applications, and facilitating the communication between processes and various devices. So, operating system architecture defines how this organization and interaction takes place. The challenges of an operating system are process synchronization, data consistency, security, resource management, and so on. And a good operating system architecture addresses this problem well and enhances the performance and reliability. So the layered-OS architecture is where the components are grouped into a layer and grouped into a fixed layer, and each layer has a particular functionality. Each layer communicates with the layer above and below it and swaps the layers above it. This type of architecture promotes modularity, as every layer has a specific functionality, and it also promotes maintainability. This is what a layered operating system looks like. Next is the monolithic architecture, where every services and functionalities of an operating system are implemented in a single kernel. This makes the communication between processes and components faster, as all of them are in a single kernel. But this lacks modularity and fault isolation, because if a single component needs to be changed or is faulty, then it affects the entire kernel. So it has a good performance but lacks modularity, reusability, and maintainability. This is what monolithic architecture looks like. Every functionality is in the kernel mode. The next is microkernel architecture, where the functionalities are grouped into user space and kernel space. As the name suggests, the microkernel means the kernel size is very small. Most of the functionalities are in the user space. This makes the architecture more modular and maintainable. But due to two layers, the communication takes more time, and thus the performance is not as good as monolithic. As you can see that the functionalities are grouped into user mode and kernel mode. The kernel mode only provides basic functionalities like file management, process management, while most of the other functionalities are in the user. Hybrid architecture aims to combine these previous architectures and provide the advantages of both monolithic and microkernel. It groups the critical component into the kernel mode and non-critical in the user mode. So it is a trade-off between both the architectures. To explain what section further, I like to come back to this.
Thank you. So next like this. Now, let's talk about process. What's the process? It's simply an independent execution unit with its own memory space. So it is fully isolated, it is not going to be shared with anyone, and it has its own separate space where it can execute its function in its own, at its own time as it is needed. So as you can see, there is inter-process communication for collaboration in the process, but there is not further collaboration as in the thread, as we are going to see further. It is managed by OS. How is a process created? It is created as it is needed by the OS. It can be created, it can be terminated, and the processes can be scheduled as per the resources available in the operating system. And there may be various types of processes that are specialized for specific subroutines or routines, and it might depend on the type of operating system that we are using. And it is operated in a separate address space. So as already said, it is isolated. So it ensures the proper segregation of data, and the data security is maintained in it. Next slide, please. So it provides fault tolerance. If something goes wrong inside a process, only that process is dominated, but the entire execution of a program is not affected by a single process. And the resource utilization can be efficient because each and every process has its own address space and has its own resources allocated to it. So the complete full utilization of them can be efficient in this architecture of OS. And the parallel and concurrent processing is available inside the process mechanism. So it facilitates the modular and scalable software design. Next slide, please. So what is a thread? We just introduced the process. What is a thread? It is the lightweight unit of execution inside a process. Let us go behind. What was the process? It was the execution unit of a program. What is a thread? It is the execution unit of a process. So it enables concurrent and parallel execution. And instead of a process which was rather isolated, threads can share resources with each other, and it is managed by the operating system, and it is written in a particular language as per the need. And the process of creating a thread and terminating it and utilizing or executing it is quite faster than a process as it is normally accepted, because it is a smaller part of a process. Next slide, please. So as process, it facilitates even further resource utilization and responsiveness, and there might be a point that the resource execution in a process might be not as good utilization as it could be, but in thread there is the sharing of resources, which is why this utilization of the resources is more efficient. So it can allow multi-threads and asynchronous programming, which is a very good part in the modern operating systems for achieving the most efficiency as possible. And scalability and performance is enhanced in this concept, and there may be some requirement of synchronization to prevent some race conditions or deadlock, so that if the resources are not available, such threads are scheduled for the later time, and the threads that are able to be executed now are executed in the initial moment of time. So it supports fine-grained control and coordination in software design. It just means in the process, the overall process was executed in such a modularity was apprehended in the process, but in thread, it is the smaller part of the process. So even fine-grained modularity and control can be done in the design portion of software. Next slide, please. So let us see here. We just write a program. What is inside the program? Suppose we are creating a Microsoft Word. So first process might be, let's create a new document. So inside that process, we are going to have multiple threads. For example, for a UI thread, in order to save the images, there is another thread, and in order to change the font, there is another thread. It all comes under one process, that is creating a new document. But in the overall program of writing a document, there may be other processes like editing the document and further opening another document inside it. So as you can see here, a program might have multiple processes, and one single process can have multiple threads. Next slide, please. So now let us go further into network OS. What is a network OS? Operating system is designed for network environments. That is the OS that are connected with each other. It may be wireless or it may be wired, but generally network OS is for a LAN type of environment, and it manages and coordinates network resources and services. So there may be data sharing and resources sharing, and the devices that are shared inside a particular environment can be utilized by all the other particular OS in different devices. And there is the proper enabling of centralized administration, and the network operations is controlled and the security is provided inside that particular environment rather than outside it. So there are some examples of network OS which are novel network, Windows Server, or some Linux-based systems as well, established. So in network operating system, it supports protocols. There are particular protocols to be followed for seamless transition and seamless sharing of resources between different environments in OS, and the network-related tasks are handled pretty well, as we can already guess. And there is the high availability of resources, and fault tolerance is very high. How? Because a single computer is connected with multiple devices, so even if one particular environment of OS is affected, another environment inside that network OS can implement the task and be not affected by the fault that was seen in the particular environment of a network OS. And the remote administration and network devices management can be allowed in this particular type of OS, and scalability and performance of this network OS infrastructure is ensured quite easy. Next slide please. So let us give an example. We have a small office. There are multiple computers. Now I want to print a document, but my particular computer doesn't have a printer. How am I going to print a document? Now there is another computer that is connected inside this network, and I am going to schedule my printing task to that printer which is not connected to my own computer. So this is how we can utilize a particular network operating system, and a network OS can authenticate if the particular computer can give the task or not, and sharing, or if the access to be provided or not. This type of tasks are done by network operating system. Next slide please. Here is the architecture. As you can see, there is particular server, and there are multiple kinds which can ask for the resources, which can do particular execution task, and this is just a demo architecture for a network OS. Next slide please. So now distributed OS. We just learned about network OS. What is a distributed OS? It is for the network of interconnected computers. But didn't we just read the network OS? What does it mean? It manages resources and tasks across multiple machines. So here is the tricky part that separates it from network OS. In the network OS, all of the OS environments were particularly connected inside a server, controlled by a server, and all of them were the clients. But here, there is the proper management, and not everything has to come from a particular server. It enables the transparent access to distributed resources. Only those resources that are distributed, that are given permission to be shared, only those are shared in this particular type of OS. And distributed file systems are supported, and load balancing and fault tolerance. It just means how much load a particular environment inside a distributed OS can handle, only that is allocated inside it. What are some examples? Amoeba, Google's Fuchsia, Microsoft's Singularity. Next slide please. So it provides distributed process management and communication. The synchronization and coordination in a distributed OS is allowed in this type of OS. There is transparency and location independent computing. That means we don't need to know where our task is being done. The task is done by giving the task or a function to any computer that is inside the distributed OS, but the location or the specificity is not needed in this particular type of OS, and it enhances reliability and availability of distributed system. Next slide please. So let us give an example. Suppose there is a group of friends and we are going to do a school project. But I might have a particular idea and I might have a particular talent in one area. Another person, another student, another friend of mine might have his expertise in another field. If it was the network OS, we would have to allocate what task is going to be done, and there will be certain functions or certain rules that everyone is going to be abide by. So that might create some conflicts, that might create some bias, and that might create some less feeling of ownership in doing that particular task. So what does distributed OS do? It acts like a project manager. So you have a talent in this, The project manager is going to analyze his talent, he is going to utilize his talent in the overall objective rather than just pointing him out and giving a task or a function. The project manager makes the execution of particular functions smooth rather than hard and fast rules. The function execution is rather smooth and efficient and effective distribution of tasks is done by the project manager. So we can understand the project manager as the distributed OS that does this with the different type of operating system environments. Next slide please. So here we can see the communication network is here, but here we can see some system have a particular disk, some system do not have any particular disk, but they are all a part of distributed OS. Next slide please. What are the advantages over network OS? As we can already guess, there is better resource utilization and balance as per the availability of resource and as per the function, as per the ability of particular system, the resources are allocated. The scalability can be improved rather than in a network OS. In distributed OS, the scalability is improved, and process management and communication between the processes, between the environments is smoother than in network OS, and the access to distributed resources, some files or anything, it is seamless and smooth. Next slide please. And there is transparency and location independent computing, as we talked about distributed OS. There is increased reliability, the fault tolerance is increased, because even if one particular function is not executed by one particular environment, another environment can utilize their resources and complete the task in the distributed OS, which is not as easy in a network OS if the resources are not available. And the performance is very high and latency is reduced though. Can anyone guess why? Okay. Because in a network OS, as we said, the environment or the network is small, may be connected by a LAN, but in distributed OS, it can be remote. The location specificity of a resource is not needed at all. So this might increase a little bit of time consumption maybe, and the latency has been decreased in the execution of distributed OS, and at last distributed file systems are supported and the data sharing is also supported in the distributed OS. And this has been our presentation for operating system architecture. Thank you.